I welcome you all for today's gathering. That is, we are going to do implement our design thinking, all the 5 stages in our course for the topic number conversions. So, in our digital system design, we have studied more about Boolean simplifications, Boolean laws, and we started with number system, right? So, there are many types in number system like binary, octal, decimal, hexadecimal. So now we are going to discuss, we are going to implement the 5 stages for all the conversions like octal to hexadecimal, hexadecimal to octal. So for each conversions we have certain policies, rules and regulations. So all that laws what we are we are carrying in our theory. Now we are going to have a discussion same by using design thinking. Yes, who is going to start first?
Good afternoon all. In digital signal designing, students are all often confused in converting bases into binary, octal and hexadecimal into numbers. In pain points, remembering division, subtraction, multiplication when they are applying in real digital circuits. Next.
Define. The core problem is how we might make the number conversion institute and less mechanicals. So learners actually understands why it's needed in a digital system. In digital system there are four types: decimal, binary, octal and hexadecimal. Decimal is a human friendly representation and binary is a machine friendly representation. Both the octal and hexadecimal is a compact representation for engineers.
So idea, think of number conversation is not a boring math. It is a translation between language. There are 4 types in idea. So decimal, binary, octal and hexadecimal. So decimal is a English, is a familiar to everyone. And binary is a zeros and ones. Okay. And next is octal. Octal is shortcuts grouping with 3 bits. And hexadecimal is a 4-bit grouping. It's a style shorthand.
So coming to the product, actually discussing about number systems. The conversion is the main thing, but some people getting some difficulties in like spelling, division, subtraction, multiplication. So let me give you some powerful techniques to understand easily about the number system conversion. Let me solve it in both where you can understand easily about the conversions. So let me take the number 13. So it's a normal number. So to convert binary, the first thing we need to do is we need to divide as a 2. So we all know that binary have 2 values, zeros and ones. So we need to divide it with the number that is 2. So by taking 2, 6 gives 12. The remainder is 1. We always need to remember the remainder. So it's very important to remember the remainder for the conversion of decimal to binary. So again I divide it. Gives 2 3s are 6 and the remainder gives 0. Again 2 1s are 2, the remainder comes to 1. So this is the main thing we get converted.
1 remainder.
Yes, 2 1s are 2.
For 3.
Yes, so 2 1s are 2, remainder 1. It gives 1 0.
There remainder 1. Near the 3. There.
2 3s are 6.
3. That 0 instead of. Sorry. Yeah, you are right.
So now we need to take from the bottom of the value to the top of the value. So it gives 1 1 0 1. And the main thing we need to do is just we convert the given number into binary. So we need to use the values 2. So it's called as a base or radix. We need to use it as 2 because we are converting the given number into binary. So similarly, because suppose we are converting the given binary to octal, we need to pair it as a group of 3 likewise we say. By pairing this 3, 1 0 1. So we have only 1 here. So before it doesn't have any value. So we can add simply as 0. So 0 0 1. We should only group as a 3 while using for octal. So using for octal, it's 1 0 1. So there is a table called 8 4 2 1. So by using that table, it's 4 2 1. So its value is 5 and its value is 1. So it gives 15. By converting the value from binary to octal, it gives 15 to the power 8. So for the simpler, for going for hexadecimal, So hexadecimal, you need to compare the 4 values. It's a 1, 1, 0, 1. The 1, 1, 0, the value of 1, 0 is D. That is D power 60. So the main thing we need to remember is, the first one is the division. That's binary divided by 2. By doing this simple conversion, it's very easy to understand the number conversion. That's the thing.
It's very good.
So for next we are going for testing. Actually, testing is based on 3 major steps. One is memory addressing. Memory addressing we use hexagonal, and next is machine code. Mostly in machine code we use binary numbers, that is zeros and ones. And the last is for checking errors. And for checking errors we commonly or sometimes rarely use octagonal. Basically, the learners have to think this as a translator between computers and humans. Then we have done.
Yeah, very good. Next. So,
Let me give some later examples, like why we are using number system is. So we are using human language. The machine language is known as the binary systems, where the actual language is converted into binary. So that's why we are using the number conversions. It's a real-time example.
yeah. I hope now it's clear with your conversions. So in this, in later we are going to also going to discuss about like code converters, like binary to XS3, XS3 to binary, and binary to gray, and gray to binary. I think you might have covered in lab classes either 1 or 2 sections. So in upcoming classes we are going to discuss about that, so that you will be very clear about from number conversions to the code conversions. Yes. Thank you all.
Thank you.